Hey fellow coders, so are you struggling to solve this LeetCode daily challenge problem called swapping nodes in linked list? If so, you are in luck. In this video, I'll tell you how to solve this problem in just few simple steps. So without further ado, let's get started. Let's try to understand the problem statement. So what we are given, we will be given the head of the linked list and we have to swap the adjacent values of the linked list. By adjacent value, what do we mean? Let's say this is the linked list we are given with example number 1 and we have to swap these two value. We need to swap 1 with 2 and then we need to swap this 3 with 4. So this is what, once we have swapped the value, we have to return the head of the linked list. So this 2 we need to return, not 2 exactly, like the head of the linked list, which is 2 right now. So for this is like, let's say this is the even number of nodes right now. We have 4 nodes, so the swapping will be pretty straightforward. But what happens if the nodes number of nodes are odd? So if let's say the number of nodes are odd, let's say this is the example which we will be given as 4, 12, and 3. What we need to do is we need to actually swap these just two values and we can leave this 13 alone. So we can swap this 4 with 12 and we can leave this 13 as it is, and this will be a resultant linked list. So hope we are clear on our problem statement. So now let's try to understand it, how we can actually solve it. Let's say this is the let's say this is the example which we need to solve it for, and what we actually need to do is we need to, as discussed, we need to swap these two values. We need to swap this 1 with 2, then we need to swap this 3 with 7, then we need to swap this 8 with 4, and again we need to swap this 12 with 13. This is what we need to do. So let's say this is my current pointer, which is right now pointing to 1. So what we have to do is we have to actually swap these two values. Let's say there is some magic operation which will swap this value, and now where my pointer will point it to after these two values will be swapped. Once my these two values will be swapped, my pointer will actually come here. 2 3. Here what we need to do, we need to again swap this 3 with 7, and once these two are swapped, where my current will be pointing, my current will now point to this value, that is 8. Now let's say we have swapped this 8 and with 4, where my current will point, now my current will point it to this value as current. Okay, so hope this part is clear. So, but what we need to do actually is we need to somehow swap these two values where my current pointer was pointing to. So let's see how this magic operation work and how we can actually swap these two values very easily. So let's say let's now just focus on these two values as 3 and 7. So let's say my current was pointing to 3 and we need to swap these 3 with 7. So let's say how we can do this. We can actually achieve this by uh, this operation. So let's say this is my previous value which is pointing to a previous values before 3, and this is my future value where my current need to point in, like once we have swapped these two values. So right now my current is at 3, and where is my previous value? My previous value is before 3, and this is my future value. So how we can achieve this is we can achieve this is using few simple steps. So let's say this previous was pointing to 3. Now after these two are swapped, where my previous should point? So if you see, my previous should now be should point to 7. So what we have to write is we can simply write is, let's say if we are writing it in Java, we can something write as this previous dot next. Where should point? Let's say this is my current value, it should point to current dot next. Okay, hope you are clear on this point why I have written this. Writing this will make this connection as previous dot next as and to current dot next. Okay, so now let's say we have established this connection. Now what we have to do is we have to establish this 7 with 3. This is what we need. How we can achieve this is we can write something like as right now we know current is pointing as 3. Where do current dot next will point? Current dot next will point to 7. So let's first go to 7, that is current dot next. Okay, and where my current dot next should point, my now this is current dot next should point to current. So current dot next will point to current. So writing this will make this connection, which I'm highlighting it in orange. So hope these two parts are clear. Let me highlight it with some values. So let's say this is red, and this have made this connection as this one, and let's say this was green and this has made this connection this one. But if you see now, making this connection, we have lost this connection. Okay, but we don't need to lose our, because after everything is done, we have to move our current to here. Okay, so after once we write this value, we have lost this connection. So to actually not lose it, what we can do is we can store this connection somewhere. So let's say I have a temp variable temp. What we can do is we can write something like as temp is equal to current dot next. So store this value in temp. So this was current, and we will some wrote something like that, current dot next. So this will ensure my this value is not lost. Okay, now if you see writing these three lines, we have something like this. But again, we have one problem here which we need to address here will be, now if you see, this is a loop. 3 is pointing to 7, 7 is pointing to 3, again 3 is pointing to 7, but this should not be a case. This connection should break. We need to break this connection. How we can break this is we can simply write this as current dot next is null. This will break my this connection. So now my linked list will look something like this. Okay, let me draw it. Let's say this was my previous, which we don't know right now. Now this is pointing to, my previous is pointing to 7. So I'll write this as 7. Okay, and where my 7 is pointing to, 7 is pointing to 3. So I'll write this as 3. Where is my current? Current is pointing to 3. I'll mark my current as this one, and yeah, that's it. Okay, so but if you see right now what we did, we just swapped these two values. Writing these 4 lines, we have swapped these values what we need. Okay, but once we have swapped this value, this 4 line would swap this value. Once we swap this value, what we need to do, we need to prepare our previous and current for our next operation. How we can achieve this is, right now my current is this. What we have to do, we have to make current as this way, and we have to make previous as this thing. Okay, but if you see, we have already stored this next variable in temp. So what we can simply write is that we can make our current as temp. This will ensure that my next operation will happen with this node. And what we can write here right now is we can also write something like as what should my previous should point to, my previous should point to current. So let's first write the previous operation so that this won't erase it. So we can simply write this as previous. Now my previous is updated to current, and my current has become as temp. So once I wrote this operation, and this my array will look something like this. My previous will, sorry, not array, my linked list. Previous is pointing to this one, and my current is this one, like what we have started. So if you see, we started as previous as this one and current as this one. Now we have previous as this 3 and current as this. So we can apply this whole operation again for my next value, and we'll get the linked list. What we need, that is swap these two elements. Okay, hope you have understood this part. This was very important. But now let's also now write the while condition. Till when this should run, till my current has become null. If my current has become null, you have to stop it. So if my current is not null, you run it, and or you also stop it if my current dot next has become null. So this will ensure if there is odd values, it will stop. Let's say that if there are 3 nodes, and this will stop my while loop. So writing this will actually So swap my values and we'll get what we want. Hope you are clear on this part. Now we can start coding. There is also one edge case. What happens if there are odd number of values? We'll address this on while we are writing the code. Okay, so now let's try to code this out. I'll be using Java to write down the code, but you can use any language of your choice. The logic will remain same. So let's write the code. So what we can do here is first we need to have the previous element. What will be my previous element pointing to its start? I'll just initialize my previous with some dummy node so that I don't have to write it again. So I'll simply write as I'll initialize my uh, with something called as -1. This is my dummy node. Okay, so now this is done, and we'll also initialize our current node. What will be my current node? Current node will point to the head of head node at the very beginning. So I'll be initializing with it head. And also let me initialize my result array, and this will right now point to previous, because my current will at last will point to the very last, but I need to maintain my result. And what I need to return after once we have done everything, we just have to return a result.next, because result right now is pointing to a dummy node, but the next element will give us the correct node after once we have done our operation. So that's pretty much this. Now we'll write the same thing what we have discussed. We'll run a loop till my current is null. Current is actually not null, and will also write when my current dot next has become not. So this will ensure that we are always in the index. So okay, so hope this part is clear. Now we'll basically write what we have written. We have will point a previous dot next to point to our element that is current dot next. Then we'll initialize something called as link node temp, and this will actually have my future reference stored here in temp variable. Then I'll write it as current dot next equal to current. This I have written as current dot next in what we discussed earlier, but it should actually be current dot next, and then it should be current dot next. We can point this to null, and that's it. We have done with the operation. We'll initialize a previous with current, and we'll initialize a current with temp, and that's it. This will actually give the value. Now one thing we need to take care is what happens if there is some node, because this if there is odd number of nodes, and this will miss the last value. That current dot next is pointing to null, so that connection will be lost. So if my current is still not null after all this operation, if my current is not null, that means current dot next was null. So if that not the case, I can simply write something like as previous dot next pointed to my current. So this will actually handle my case where the number of nodes are odd. Uh, yeah, that's it. This will handle everything, and we are returning our answer, and this will swap the elements, and this will take care of our odd number of case. Let me try to run it. I hope there is no compile error. Apart from that, the logic looks okay. Here it is. Current, if current not equal to null, or current dot what it is saying next, because local is null. Okay, it looks like something as null pointer error. Let me check. Previous dot next is current dot next. I'm initializing my temp with this. I'm making my current as current dot next I'm making as previous. I'm making it as current, and current I'm making as this temp. Okay, actually this should be and. Okay, my mistake. Now it should work. Let me try to submit it. Okay, hope you have enjoyed this value we not value video. If you have enjoyed it, please leave a like and let me know what is the next video which you want to watch. See you on the next one. Bye.